were basic SOHCAHTOA ones, basic graphs, basic triangles. Your right triangles. You know two things for a right triangle. You know Pythagorean theorem to find a missing side. Or to find any angles or functions, you know SOHCAHTOA. Use your trig functions. Sine, cosine, tangent. That's all you know about a right triangle. So it's got to be somewhere in there. Find your missing side. This is one of your triples. The triples, when they work out nicely, like 3, 4, 5, that's a triple. 49 and 41, that's a triple, that's a triple. The ones that work out nicely are called triples. Now, when we go through this, use your SOHCAHTOA. This is the easiest part right here. Then take the reciprocals. A reciprocal says flip it over. If you take sine and you flip this over, this is your cosecant. We learned what the reciprocals are. So then you flip this part over and you get its cosecant. You're flipping over both sides, technically, when you find its reciprocal. See, like when you go do those special ones, you can flip them over. They work nicer. So these pretty much were finding the missing side, being able to find all 6 trig functions. Good? Questions? Do not pick up your calculators on this. If any of these fractions can be reduced, then reduce them. But leave them in fractional form. Okay? Number 13 and number 11, same thing. I was hoping in number, what number is this? Oh, number 11. I was hoping in number 11 that you kind of saw the difference right here. See this little triangle right here? It's a multiple of 4 of this one. Now, if you saw this, you know how you had to reduce all these fractions? If you reduced it here, if I divide everybody by 2, I get a 3, 4, 5 triangle. If you used your 3, 4, 5 triangle, it would automatically reduce it down for you. It would reduce it for you into your 3, 4, 5, because you had to go back and reduce these. So it reduced it, yes. What's that?
If you forget to reduce,
you have to reduce your fractions. Yeah, I will. Yeah, you have to reduce your fractions. Everything that you do is to lowest terms. Your radicals to lowest terms, your fractions to lowest terms. And this was actually a multiple, this was a multiple of this guy. If you multiplied, if you saw this, from 2 to 8, if you multiplied by 4, then you multiplied this one by 4. And then you could figure out, divide this by 4, and get this missing piece. It was, what are these called when you do this? When they're the same shape, same angles, equal angles, but different sizes in proportion. What are they called? What kind of triangles? Similar. Those are similar triangles. The sides are in proportion. So once you establish that proportion, go with it. You can reduce this down. This was a great problem. I kind of wanted to see what was going on. If you notice, you probably looked at this and said 1.5 over 2.5 doesn't say 3 over 5. But it is the same fraction. If I divide this by 2, divide this by 2, I get 1.5 over 2.5. If you cross multiply, you would see that they're equal. No, but I kind of wanted you to see that this was a multiple of this one. Because don't they all work out, regardless of your similar triangles, they work out the same sine, cosine, tangent? Jen?
Would that be on this test?
I don't know if it's on the test. But do you see what I'm getting at? Do you see? I want you to see the concept here, guys. Shh. The concept. The concept of what's going on. These are your similar triangles.
So we're not having a quiz tomorrow?
No. No quiz. No. Because we're kind of off on this whole thing because we lost like what, 5 days? 8? 6 days? It's crazy.
Always counting.
And actually, one day we deserved Monday. Monday we did have off.
So 5.
Tuesday.
She was right.
We should have
What's this?
Okay, guys, let's stay with this. All right. Now, the second part, they gave you a function. And we did this. We did the cosine 5 over 7, and we set it up into our triangle. And we still found the missing part. We found the opposite adjacent hypotenuse, and we went with it. If you're on a coordinate grid, x, y, and r, and then go with it. So we found the secant to be 4. Put it 4 over 1. If it helps you, if you take this and you flip this over, and you flip this over, what is 1 over the secant? What function is that? What's the reciprocal of secant? Cosine. So if you wanted to, you could go here, x over r, if that's what you see better. Flip it over, take its reciprocal, and set up your triangle. I want this. I want this information box. So then now, if you did x, y, or r, or you set it up whichever way you wanted to do it, you didn't have to put it. I don't think that one had it on there, but you could. X, this is y, this is x, this is r. Now you can find all your pieces. Again, you don't have to rationalize your denominators anymore. Okay? All right? Number 17, same thing, tangent. Put it over 1. There's your y over x. You've got one more piece to find. Find your missing hypotenuse, your radius. Give me all your pieces. These were in quadrant 1, I think. They all said from 0 to 90. Was this the one that said from 0 to 90?
No.
No? Was the other piece? Okay. Questions? Girls, you need to take that work and do something other than talk. That would be a good thing to do in this class. Okay. All right, moving on. Cotangent. If you prefer to do tangent, flip this over. 1 over cotangent is tangent. Flip this over. Y over x. It'll work out the same. If you prefer to use your basic 3, use your reciprocals. It works nicely. Find your x, y, and r. Is there anybody that cannot do one of these? Given a function, can you put it on a triangle, find the missing part, and find all 6 pieces? Yeah?
I think the angle part is what gives us.
The angle part gets you confused.
Yeah.
Okay.
Yeah.
Here, I want everybody to do this one right now. Obviously not making this up. Okay. Quadrant 1 angle. Let's, you know what, let's make this a, yeah, keep it quadrant 1. Keep it a quadrant 1 angle. Let's take the cosine and let's flip this over. So, cosine is which piece? X, Y, R. What is it? X over R. 7, 9. What piece are we missing? The Pythagorean theorem here, we're missing the Y. So, 49. Guys, I don't want to hear you talking. In a minute, you're going to get a quiz on this.
What?
Yeah. It's odd. For the past 2 days, I've been doing the same thing.
I got 4 together. the radical 2.
Okay, so let's see. What does that subtract at? 32?
32. Then 4 radical 2 is the...
Okay. So can I leave it radical 32? No. I have to take this out to a perfect square, and that's a perfect square.
16 and 2.
16 and 2. So, 4 radical 2 works for me. Now, cosine. Cosine x over r. We already found your cosine right here. Your sine, y over r. 4 radical 2 over 9. Can this be reduced at all? No. Tangent, y over x. Can this be reduced? No. There's your pieces. How hard was that? Not at all. Not at all. Guys, you have to memorize. If you don't know your reciprocals, I suggest you memorize them. If you don't know Pythagorean theorem, I suggest you memorize it. The easiest way is to set this triangle up, make an information box. Without the triangle, I can't visualize what's missing. It's very hard to see what's missing, especially if we put this in a different quadrant. If I took this one and I said, let's put this in quadrant 4. I'm putting this in quadrant 4. So I label my sides 9 and 7. I find my missing piece. The same way, right? Everything's the same so far. What's different? The y is negative. Very good. My x is positive. My y is negative. Where's my negative? And my r is always positive. So now my sine is going to be negative. My sine and my tangent will change. My tangent will be negative divided by a positive. And that's the only difference. I'm moving that to another quadrant. Okay, let's go back to this one and do your special triangles. All right, this is a whole section on special triangles. So I come here and I say, okay, let's flip this over. I'm put this over 1, so 1 over secant is equal to 1 over 2. What is 1 over secant? Cosine. So I've got the cosine of my angle to be 1 over 2. X over r. If it helps you, flip it over, use the reciprocal. If you can look at it and say x over r should be r over x, then that's absolutely fine, r over x. Once you fill this in, 1 and 2, if you use the Pythagorean theorem, you can find radical 3. If you don't, you should almost recognize this to be 1 doubled is 2, add them together, radical 3. What angle is this across from the radical 3? 60. This is a 60-degree angle. That's all I wanted to know. And how many times does 60 go into 180? 3. Pi over 3. Okay? So we get to here. Cotangent. Cotangent is the reciprocal of tangent. So instead of y over x, I'm x over y. Since I don't have one, I put it over 1. What happens when x and y? My both sides are 1. What's my reference angle? 45. When my both sides are the same, I have an equilateral, I have an isosceles right triangle. I have a 45-degree angle. So this is all I needed to know out of that. Okay?
You have to write the angle pi over 4 too?
You had to write it in degrees, and then they asked you to write it in radians as well. But Aaron, all you have to do since you're in quadrant 1 is take 45 and divide it into 180. That's your bottom number.
Oh, okay.
That's all you have to do. Same as reverse of the other one. You know when you see pi over 4, you say 4 goes into 180. 45, it's just the reverse.
Okay.
Okay? This is a little tougher, this one. This one's a little bit confusing looking. So I don't really like to look at my cosecant, so I'm going to flip this over. What is 1 over my cosecant? Sine. So I have the sine of this angle as 3 over 2 over radical 3. So if I work with this and I set my triangle up, this is my r, this is my other side. Now, if you do Pythagorean theorem on this, and you're going to have a little hard time recognizing this guy, but if we do a Pythagorean theorem on this, when you square this, you square the 4, you square the 3, and 4 times 3 is what? 12. So, oh, sorry. So this gives me a 3. And a is radical 3. Now, this is a little bit difficult to look at. Do you recognize it at all? What do you recognize it as? Aaron, what do you recognize it as?
The same thing as the other one, isosceles right
Not your isosceles, because your sides are not the same.
there. Oh, yeah, this is one of
Oh,
them.
you're.
No, these? No?
Oh, you are the other guy.
I'm doing this one. I'm doing this one. Yes.
Oh, okay.
This is harder to recognize, isn't it? Here is your special triangle, watch, for your 30, 60, 90. Watch. This is 1, 2, radical 3. If I want this guy to be 2 radical 3, look at the difference from here to here. I want to multiply this guy by radical 3. I have to multiply everybody by radical 3. I'm multiplying by radical 3. I'm multiplying by radical 3. What does this give me? 3. So, does this look the same as that now? Yes, it's harder to see when they reverse the radicals. I'm going to show you an easier way in 1 second. But it is doable because it had to be one of your special right triangles. Could I also put this in my calculator, second sine, and figure what angle was that? I could absolutely put that in my calculator, second sine, plug this mess in, and find my reference angle. Now, remember what they did here is they rationalized. It's if you can spot the rationalization, if you got the radical 3 here, you probably had the radical 3 here, right? Because if I multiply radical 3 by radical 3, I get 3. If I multiply the top by radical 3, I get whatever, radical 3. So what did this number was up here in the numerator before I rationalized? I'm going to multiply top and bottom of this guy by radical 3. So what was my numerator before I rationalized? 2. So now, this might make more sense to you. Let's flip this over. And this is my sine. Ah! Now it makes more sense to me. So my sine is radical 3, 2, 1. It's easier to do it without the rationalization in there. Before it was rationalized. I mean, it's doable, but what happens here is it reverses where you expected to get a radical, and we got a radical in your radius instead. It reverses it a little bit. So it is doable. This guy too, this is probably more recognizable for you. Radical 2 over 2 is what angle? Is your 45, right? That's what Aaron was getting at. If I unrationalize this guy, what do you think was in my denominator? I want to get back before I rationalized it. What do you think you multiplied top and bottom by? Square root of 2, radical 2. And what was in my numerator? 1. Ah, isn't that your cosine and your sine of your 45? It's easier to, this one wasn't bad because we know and always say radical 2 over 2. When you're looking at that one, that was a little bit more difficult to unrationalize that one. But these are your special triangles. You have to know those special triangles with your eyes closed. Literally with your eyes closed. Very easy. The hardest part is drawing the sketch. So, I have a 100-foot line is attached to a kite. When the kite is pulled taut, which means it's tight, the angle of elevation to the kite is approximately 50 degrees. Find the height of the kite to the nearest 100. Now, when you fly a kite, and I'm holding the string, is the kite above me? No, it would fall on my head. Where's the kite? At a diagonal. So let's draw my kite attached to my string, and I'm holding it. How do I measure the height of that kite?
By going to the ground.
By going straight to the ground. I make the H. Okay, I went a little bit below the ground. Are they a little below the ground? Okay, so isn't this the height of my kite? That's my height. I'm not going to call it H, though, because I don't want to use H for hypotenuse. So now, where does the 100 go? Let me label A, B, and C. Oh, the 100 is the hypotenuse. Isn't this the string that I'm holding to my kite?
Yep.
And it's a 100-foot line. Where does the 50 degrees go? Angle of elevation.
Where you're standing.
Where I am, right here. When you have an angle of elevation, you have your eyes on the horizon and you elevate them like this. You make that angle inside your triangle, from lowering it down here to going like this. That's your angle of elevation. It's inside your triangle. Now, which letter do I want to find? B. I want the height of my kite. So this is a right triangle. This is my angle of reference. I have my hypotenuse and my opposite. So if someone says sine, so sine of 50 degrees, opposite over hypotenuse.
Question.
Yes.
Can't you like draw signs or something?
Well, you really, you wouldn't want to. You can't use law of cosines. It's not an angle side angle. And your law of sines, you could use a sine of 90, which is 1, which gives you the same thing as a plain old sine of 50. When you set up law of sines, and you set it up the opposite 100 over sine of 90, sine of 90 is 1. So that 100 just comes out where you want it. So we actually don't do the law of sines and the law of cosines here. We just stick to the basic trig functions. But you could use it if you wanted to. So now, when we get here, we're going to cross multiply, right? To solve for B? Two things. The mode has to be degrees. Secondly, when you cross multiply this, you get a parentheses with your 50. You need to close it before you multiply by 100. Otherwise, you'll be multiplying the angle by 100.
Can you say it one time?
Okay, when you check your mode, make sure it's degrees. Now, when you cross multiply, when you say sine 50, your calculator gives you this parentheses.
Oh, yeah.
If you don't close it, it's going to look like this. 50 times 100. You're going to multiply your angle by 100. You don't want to do this.
When you put it in front.
So you can put it in front. You can put it in front. Now, round it to the hundreds. How many decimals is the hundreds? 2. Good. And we'll label with feet. Now, let's see if it makes sense. Shouldn't this part of our triangle be less than the hypotenuse? Yeah. So we're okay. If we were greater than the hypotenuse, something's wrong. If we came out with a negative number, we're probably in radians. If you come out with a weird thing, always go back and check the degrees. Even though you think it's your calculator and you left it in degrees, always check. Okay?
I just want to see what's set up with
Okay.
I'm glad you like my voice. I'm kidding, it's a joke. Alright.
Are you good?
Yeah,
No, are you good though? I don't want to move it if you know.
I'm good.
Good?
Just more, why did you multiply?
How do you solve fractions? You cross multiply.
Oh, yeah.
What if I did this?
Yeah, that was a simple question.
No, it's not. No, what throws it off is seeing the word sign in there.
Yeah.
What throws it off is it doesn't look like a regular.
Like a regular, yeah. Oh, what? I don't know. This camera, you can stop teaching in class.
Good try, good try. Good try.
And don't live for
Okay. Here's the tough one. But this one's easy though. This is not involving your non-right triangle. We're only going to use right triangles in this one. You have a point, at a point 200 feet from a base of a building. The angle of elevation to the bottom of the smokestack is 35 degrees, and the angle of elevation to the top of that smokestack is 53 degrees. Find S, the height of the smokestack. Now, let's take it apart. I'm at a point 200 feet from the base of a building. So, first thing I need to draw is a building. Now, my base of the building is here, isn't it? I'm 200 feet away. Could I be up? Nope, from the base of the building, I'm 200 feet away here. Now I'm looking at a smokestack. Where is the smokestack located?
In the air.
In the air? But on top of, all by itself? On top of your building, right? On top of your building.
It's still in the air.
Yeah. So I'm looking at the bottom of the smokestack, and my angle of elevation is 35 degrees. Hang on. Now, I'm standing in the same place. I raise my eyes further up to the top of the smokestack. Just I stay right there. Now, this angle is 53 degrees. Okay, I want to find S, the height of the smokestack. How many right triangles do you see? You see one. Which one do you see? You see two? Do you see two?
Oh,
Okay, I see one here. Watch my.
yeah.
Oh,
Here.
wait, no, never mind.
The third one is a non-right. And then here's the second one, the big one.
I thought you said how many triangles.
How many right triangles do you see?
Oh, my.
Two. They're nested together, right? Each one of them shares the same base, 200. They both have a different angle of elevation, and they both end up with a different side. Now, let's call the height of the building B. So, if I find the height of the building, and then I use this large triangle, and I say this height is S plus B, agree? So if I do S plus B, and I take away B, won't I be left with S? So that's our goal, to say S plus B minus B equals S. But we're okay, because watch. We have a triangle with a side and an angle and a missing side. Can't we use trig to find this? So if this is my angle, this is my opposite, this is my adjacent, what am I using? Tangent. So when I find B, this is the tangent of 35 is equal to my opposite over adjacent. How do I solve for B? Tangent, opposite, over adjacent. I'm in this little triangle down here, right? So I cross multiply. I get 200 tangent of 35 equals B. This part goes in right there, doesn't it? Now, I'm going to do the same thing with the big triangle. I'm going to solve for the S plus B. So I've got an angle 53. S plus B is my opposite side. So the tangent of 53 equals S plus B over what? 200. I have the same base. So again, I cross multiply. Equals S plus B. So now, can I replace that in there? I found two tangents.
Kind of got lost after you did
Okay.
200 times 35.
Okay, hang on. We said that this big right triangle over here, right, has a side over here of S plus B. So if I'm looking at this big piece, this is 53, this is S plus B, this is 200. So tangent, opposite over hypotenuse. Tangent of 53 equals the opposite, which we called S plus B, over 200. I want to solve for this so that I can replace this. So I cross multiply. Now, my S plus B, I can take out and replace with 200 tangent 53. So I end up with this. 200 tangent 53 minus, I take B out and replace it with this, 200 tangent 35. When I take the height of this whole thing minus the height of my building and be left with the height of my smokestack? So we do that, and tell me what you get. Round it to the tenth.
Two.
Put it in your calculator just like you read this. I want the final answer. Never do them in between. Do it one time at the end. Try to pull all your rounding things at the end.
I got 125.
Good. This is feet. So we found the height in feet of the smokestack, which is pretty big for a smokestack, isn't it? Pretty big.
125 feet.
I think that sounds pretty big. Okay.
That's freaking huge.
Yes.
Wow.
So, Ricky, any questions?
Yeah, Ricky.
Yeah.
Since you like to sit shoot.
Guys! Oh, oops. Sorry.
They're right.
Wow. That's crazy. Ricky,
Okay. My diagram is a little bit different than your diagram in this. Yeah, I'm going to see if I can draw yours. Maybe while I'm doing this, you could be reading this. And it looks kind of out of proportion, so don't worry about the out of proportion part. Okay. A spacecraft is traveling on a circular orbit. Here's your circular orbit. I extended the 150 so that you could see it, but actually it's very small. It should really look like this one, the original one I drew. Theoretically, yes. It's circling 150 feet above the Earth's surface. From the angle of depression, the angle of depression is here. The angle of depression actually is here. That's kind of drawn a little bit wrong. The angle of depression is drawn to the other side. It should have been the other side. The angle of depression to the spacecraft at the horizon, we have to find the angle of depression. Now, assume that the radius is 4,000 miles. Now, let me explain the angle of depression. If you're looking up at something like this, this is your angle of elevation. Your angle of depression is when you're sitting up here and you're looking down. Your eyes go from the horizon down. It goes like this. So if I was to extend this line and extend this line, what do I know about angle A and angle B? Good. They're alternate interior angles. Bam is right. So they are congruent. Your angle of elevation and your angle of depression is the same angle. Don't get confused with these two. These two over here, one is complementary of the other. But your angle of elevation and your angle of depression are the same. So we can also assume that we're finding this angle in here. Because they should have put their angle of depression over here. Now, if we do this, and I'm looking at this triangle, and this is a hypotenuse, and this is an adjacent side, what function do we need to find cosine? Cosine, this time, of a missing angle is adjacent over hypotenuse. So we're going to fill in this piece over here. My hypotenuse should really be what? Not 150, but what? It has the radius here, which is 4,000, plus 150. This is obviously not drawn to scale. 4150. So you've got adjacent 4,000 over 4150. I tried to redraw it because I didn't like their drawing. I didn't like their drawing at all because it also makes the 150 look so much bigger than the radius. So their angle of depression is off. So their whole problem here is not a good looking problem. But I like finding the angle. So now, how do I find the angle? I want an angle whose cosine is 4,000 over 4150. Right. I do second cosine.
I do that.
There you go. Invert.
It was in my head.
But I had it one.
It wouldn't come out.
And round it to the nearest tenth of a degree. I don't know what's going on with that. To the nearest tenth of a degree. What do you get? What do you get? 15.5 degrees. Thank you. Okay? And the last one, everybody good with this so far? Nope. Is there one more on the paper? Okay. Add this one
Oh, there is one on the bottom.
on the bottom. Okay. Now, I said in quadrant 2, find all 6 trig functions. And all I gave you was a line y equals negative x. So we graph the line. So, Ricky, where is the line y equals negative x? Yeah, this way. And what does it do to this quadrant? It cuts it in half. Ah, it's a 45-degree angle. So, 1, 1, what's the radius?
2.
Radical 2. So what's x in this quadrant? Negative 1. What's y in this quadrant? 1. What's r in this quadrant? Can you find me all your pieces now? Yes, you can. Yes, you can.